All right, so in this video, we're going to go through sample question number 83 from the Society of Actuaries ExamP list of sample questions. The question reads, a company manufactures a brand of light bulbs with a lifetime in months that is normally distributed with mean 3 and variance 1. A consumer buys a number of these bulbs with the intention of replacing them successively as they burn out. The light bulbs have mutually independent lifetimes. We need to calculate the smallest number of bulbs to be purchased so that the succession of light bulbs produces light for at least 40 months with a probability of 0.9772. Okay, a lot of words here. This is another central limit theorem problem. If you're kind of going through these questions in order, there's kind of been a group of these that you would have just gone through. So what are we being asked to find, right? Let's say we need to know the smallest number of light bulbs. That's what we're trying to find, number of light bulbs. So we'll call that n, right? I'll just refer to this as n. So what is n? N is the total number of light bulbs. We need the total lifetime of all those light bulbs. I'll refer to that as T, okay? Whereas I'll refer to X as the lifetime of a single light bulb. We know the lifetime of a single light bulb is distributed with mean of 3 and variance of 1. So the sum of all these should be normally distributed, just like each individual one's normally distributed. That's basically the central limit theorem, okay? So the total lifetime of all these bulbs is going to be normally distributed with a mean of 3 times the number of light bulbs we have, which in this case is n. 3n is equal to mu. And a variance of, well, n times whatever the variance is, right? Which is 1. So our variance is equal to just n. Okay, meaning our standard deviation is the square root of n. All right, so it's important to know how I kind of arrived at these numbers. All right, I'm looking for basically the total amount of light produced by some number of light bulbs, and I called that T, and I use the central limit theorem to find the important numbers, mainly the expected value and the standard deviation. So where do I go from here? Okay, I know this total, right? The probability that this total, the total amount of light produced by all of these bulbs, should be greater than 40 months with a probability of at least, right? This probability should be at least 0.9772. Okay. Once I have this set up, I can now start doing the, normal distribution thing that you're probably very used to by now. Okay. I'm applying this formula, right? Writing in red. It's a new thing I'm doing just because it's that important. Just like that, okay? And I'm going to apply it here. So this is now the probability that T less than what is my my mu value, that's 3n, over the standard deviation, which is square root n. That's got to be bigger than 40 minus 3n all over the square root of n. Okay, now this implies n should satisfy the following equation. It should satisfy whatever the z value of this is, which we need to look up on the normal table. Okay, so looking this up on the normal table, we find that in order for this to be true, this is going to be -2 is greater than or equal to 40 minus 3n over square root n. Okay, the reason why it's negative 2 and not positive 2 is because of this greater than sign. Okay, so now we just have to solve. This is just algebra, right? This is just straight up algebra. We need to find a value for n such that this is true. I'm going to change this to an equal sign. Negative 2 equal to 40 minus 3n over square root n. I'm going to multiply to both sides by n. I get negative 2 square root n equals 40 minus 3n. And I'm just kind of speed through this part because you don't need to watch me do algebra. That should be something you're very familiar with at this point. But there are actually a couple of ways you could solve this. I'm just trying to see which way I want to go about it. You could bring everything to one side, use quadratic formula. You could try to factor. I'm going to see if I can get rid of this root, just because I don't like dealing with it. So this will be 4n equal to 40 squared, which is, I believe, 1600, right? Double checking. Yes. 1600 minus 240 n plus 9n squared. That is a beautiful thing we just created. Okay. I'm going to bring this over to this side and rearrange this. So 0 is equal to 9n squared minus 236n plus 1600. Okay, I'm going to use quadratic equation on this. So, if you're familiar with quadratic equation, you should be. That's going to be n is equal to negative b, so that's going to be 236 plus or minus the square root of b squared, so that's negative 236 squared, minus 4 times 9, which is the a value, times c, 1600, over 2a, so over 2 times 9, I'm just going to write that as 18. That's all over. All right, so I'm going to put this into my calculator. I am kind of regretting getting rid of that square root, but not too big of a deal. 236. First I'll do plus the square root of negative 236 squared minus 4 times 9 times 1600 over 18. And okay, there are two values. One's negative and one's positive. So since time can't be a negative value, we have to go with n equals 16. And that's our final answer. All right, so let's quickly go over what we just did here. So we're told that we have some light bulb, right? It's got a lifetime of 3 and variance of 1. They're identical light bulbs, we assume, and they're independent from each other. Whether or not one light bulb fuses early does not affect another one. So we can use the central limit theorem to approximate the total lifetime of multiple light bulbs. And we did that here, right? We just don't know how many we're dealing with. Once we got our important values of the standard deviation and the expected value, we then put it into a probability, right? We need the probability that this total amount of time exceeds 48 hours to be greater than 0.9772. Apply a z-score to the formula. And from there, we can figure out that -2 is greater than or equal to 40 minus 3n over square root n. Okay? Now, I skipped a couple of steps here, but, well, it's mainly one step, and that is to change this so it's 1 minus some value, right? That's how I'm getting a -2 here rather than a positive 1. And the rest of this is algebra, all right? So if there are any questions, throw it down in the comments. I'll answer to the best of my abilities. If you want to see more videos like this, I got a playlist, right? Sample exam P questions. And if this video helped you out, hit the like button, subscribe, because that totally helps me out, right? But other than that, thanks for watching.